Welcome back to my workshop. Now today we're not going to make anything, but what we're going to do is fix something. I've got a power tool here, doesn't work, let's make it fixed. Right, so what I've got here is a battery powered circular saw. Okay, it doesn't matter what brand it is. This video is hopefully going to talk you through the basic diagnostic principles or fault finding principles of how to fix something like this when it doesn't work. Okay, so it doesn't matter if it's a circular saw or a jigsaw or a battery powered sander or a battery powered rotary tool or even battery powered angle grinder. So because they're all battery powered, the process of finding out what the problem is going to be pretty much the same. Now with this one, it had a particular failure mode. Let me talk you through that quickly. So what happened with this one was, it's a relatively cheap tool. It's from Aldi's. It's a work zone circular saw. I've had it a few years, but I'd only used it for a couple of months and then it stopped working. But before it stopped working, it was cutting in and cutting out. So I'd go to use it, one time it'd work, I'd move it about, oh, then it'd stop, I'd move it about, it'd start again. So I suspect, so my first impression was that there's a loose connection somewhere inside. So what we're going to do is we're going to take this apart and search for my loose connection. Okay, but we'll do some other checks on the way. But first of all, we need to understand what's inside before we even start taking it apart. So let me draw you a picture over to the design studio. So what's inside? Well, all of these tools have got things in common. Okay, first of all, they've all got a battery. Okay, so that means to me all of these tools are DC powered. Okay, not AC, they're not corded, they don't plug into the wall. They're a battery, so they're DC powered. So we know it's going to be a DC circuit. You don't have to know the difference, but I will describe in a minute. Okay, also they've got a trigger, okay, which is just basically a switch. Okay, so a battery, a switch, and finally they've all got something spinny. Okay, so there's a motor. This in this case spins a blade. With the other ones, either a drill, it will spin the chuck. With the angle grinder, it will spin a cutting disc, etc. So we've got a battery, we've got a switch, and we've got a spinny thing. Okay, so what does that look like as a circuit? So in a circuit diagram, the battery is normally represented by a series of lines. Okay, so if you ever see that on a circuit diagram, that is a battery. Okay, in our case, this is a 20 volt battery. Okay, 20 volts. There's no questions in this. I'm not asking you to do anything. I'm just showing you what's what. Now, at the other end, we've got the spinny thing, which is obviously the motor. Okay, in this case, we've just got a motor. We know it's a DC motor, so it should, in theory, only have two wires in this case. Okay, and we also have a switch, which is the trigger. Okay, so switch is drawn like this. Okay, and this is all connected up very simply. It goes from the battery to the switch, from the switch to the motor. This is the motor, and then from the motor it returns back to 0 volts. Okay, or ground as people call it, or earth as people call it. Okay, but this is 0 volts. So this end we're going to have our 20 volts, and this end we're going to have our 0 volts. That's a circuit. And the simple principle is, you push this switch, it makes this circuit, it makes this go round, okay, and it returns to the battery. Okay, so pulling the switch makes the motor go round. That's our entire circuit. Now on some tools, obviously it goes into more depth because you've got variable speeds, you've got different lights and flashing bells and whistles, but this is the basic principle, and this can be applied to most battery powered tools that are in your workshop. So if they break, there's a chance you might be able to fix them. Right, so I know it's a bit of an old cliche, but before we start taking something like this apart, let's think safety first. What we're going to do is, first of all, take out the battery. Okay, we're going to look at that in a moment. but also on this, because obviously it's got a big nasty spinny blade, we're going to take the blade off. So let's just grab an Allen key. There's one. This is a spinny lock here. It is. So righty tighty, lefty loosey. So now if something happens and it spins, I'm not going to chop bits off my hands. All right, good, it's safe. Okay, so one of the most important tools we need to fix this is one of these. Okay, it's a digital voltmeter. This one's a fluke, so it's quite a good one. Now, you don't necessarily need to have a really good meter. You can buy some relatively cheap ones online or in Halfords or somewhere like that. Okay, but it must be able to read resistance, okay, which is this ohm sign here, okay, and also voltage, okay. And because we've got a battery like this, we need DC voltage, which is this symbol here. Okay, so it's a little V with dashy lines above it. Okay, not the wobbly line one, the dashy line one. Okay, right, you don't need to be an expert in how to use this, but I'll show you how to use it on this one for this purpose. Right, before we take the saw apart unnecessarily, let's first check the battery, okay, because these tend to be the weakest component on the whole tool. If it's going to go down, the chances are the battery's gone down first. Now, in my case, the saw, you just pull the trigger, nothing happens, there's no lights or anything. But I've had this quite a while, I've had this battery on charge, and I suspect the battery's okay, but I think it's the tool. But to check the battery, first of all, if you've got a charger, which you should have, if you've got a battery, put it in, see what it's doing. Okay, this is obviously recognised the battery is present because it's showing that it's not charged fully. Okay, so I have had this on charge and it does charge up and then the light eventually goes green. Okay, so I'm assuming this battery's okay, but what we're going to do is, because I've had it a long time and I've had it on charge a lot, I'm going to have a quick look inside this battery. Some batteries you can't get inside, but this one you can. So what I'm going to do is I'm going to quickly look inside the battery to make sure none of the batteries are damaged or broken. Okay, in this case it's just 4 screws. You probably can't see anything apart from my hands. Okay, obviously be careful when you're taking a battery apart because there is power there. It's not a great deal, but it's enough. Okay, 4 screws off. Now this should open across here. Yeah. Okay, so there's our battery. So each one of these is a cell and this whole lot makes up the battery. So what we should be able to do is look at the actual circuit, make sure there's nothing burnt, make sure there's nothing wet, there's no evidence of any water or anything like that. And this one looks okay. Okay, spend some time looking at that. And what I'm going to do is quickly individually check each battery to make sure it's got a decent voltage. Okay, that's where my digital voltmeter comes in. Okay, so what I'm going to do is I'm going to put this on volts DC. Okay, so you can see on the screen there, which you can see hopefully. So each of these should be, is it 3 point something volts? Let's have a look. Can you see that? Good. Okay, 4.15 volts. Okay, and I'll check the next cell. 4.14. 4.15. 4.14. 4.15. Okay, so they're all fairly well balanced. If I go from one end to the other, I get my 20.74 volts. Okay, so I'm going to assume these batteries are okay. I'm going to reassemble it. If I can remember, I took it apart a good 4 seconds ago. Okay, remember, don't force anything when you're putting it back together. It should go back together fairly simply. Okay, So that's our battery back together. Now if we wanted to, if you look on the battery here, it shows you the positive and the negative sides. So again, if I check across those, it should give me my full battery voltage. Okay, black to negative, red to positive, all right, 20.24. Okay, all right, I'm happy, the battery's okay. Let's get onto the saw. Right, so what you must remember with these tools, they're all made on a production line. They're made very quickly, so they need to be assembled quickly by, you know, various people that, you know, they don't have to be special technicians or anything. They need to be able to assemble these. So they're all assembled in a sequence, okay? It's not the same for every tool, okay? But what it does mean is that you shouldn't have to struggle to get anything off, okay? Things should just be able to assemble and disassemble, okay? If it's been put together, it should be able to be taken apart. Okay, now if you look here, this bodywork here is held together by loads of screws. Okay, the back of this is obviously the motor. The back of the motor is held in with these two screws. So what I'm going to start with is I'm going to look at the back of the motor and I'm going to check the motor to see if there's any problems there. So this cover, got to take it off, and it should be just these two screws. Okay, probably a good idea at this point to get yourself a little tray. Okay, something like this. So you need to go out one night and have a Chinese. Okay, put all your screws in there because I can guarantee you will lose some. Okay, then this cover should hopefully come off. There you go. And you can see the back of the motor. Right, so this is going to be our first test. Right, so for this first test, now we don't have to understand the full principles of how a motor works. Some of them can be quite complex, but this in theory is a magnet and a coil of wire. Okay, the coil of wire goes from this pole to this pole. Okay, so between these two poles we should see a complete coil of wire, okay, which means it should effectively be connected together. So when I probe it with these two probes, I want them to actually appear to be joining together with a low resistance. So if you look at my meter here, I'm going to set this to ohms, okay, which is a measure of resistance. If I connect my two terminals together here, okay, you'll see that it comes up with 0.1. Okay, that means it's a short circuit, which means that's good connection between this pin and this pin. Okay, so when I go across the motor here, what I want to see is a very low value on here. Okay, and then that tells me there's no breaks in the coil of the motor. So I'm just going to go between this terminal here and this terminal here, and I get 0.2. Okay, so that tells me the motor is not broken because the coil of wire is being seen from one terminal to another, and it also tells me the brushes are in good contact with the inside of the motor. All right, as far as we're concerned, the motor is going to be okay. All right, so it's possible that could still be wrong, but for a quick check that will be sufficient. Right, let's look at the connections to the battery. Okay, on this one there's only two terminals because it's a very simple motor. Okay, on some of them they have a third one which can be used for temperature detecting, for overheat protection, etc., or for stopping you using a dodgy battery or anything like that. Okay, but this has only got two. So basically, let me show you on the circuit diagram what I'm looking at this bit here. Okay, so on our circuit diagram here, let's just get rid of some of these numbers because you don't need them at the moment. All we need to know is this is positive and this is negative. Okay, now what we've done is we've taken off the battery. Okay, so we've basically open circuited it here and here. And we've taken this and we've moved it out of the way. Okay, so the two terminals I just pointed at is this point here and this point here. So if I put my meter across those two terminals, so here and here, okay, what I should see is all the way through the motor and then back to that point. Okay, but that's obviously with this switch closed. So what we're going to do is we're going to put our meter on here, pull the trigger, and we should see 0.2-ish on our meter. Okay, so basically a short circuit. As soon as we shut this switch, we should see continuity. That's the plan. Okay, that's just telling you what it's doing. Let me show you what it actually does. Right, so we're ready to do that quick test. We've got our meter here set on the ohms sign. Okay, this is measuring resistance. These are the two terminals I want to check. Okay, what I've done is I've put some little clips on the end of my probes here just to make life easier. Clip one on one of them, and the other on the other. Okay, making sure they don't touch, okay, or don't move together, because then you'll start getting readings on here and it won't make any sense. So the simple test is going to be to pull the trigger, and in theory that should make a complete circuit through this, through the motor, and then back to the other side. And this should give us a really, really low resistance, okay? Or it should show us continuity. Okay, so let's pull the trigger. Nothing. Okay, absolutely nothing. So this supports my theory that there's a broken wire inside somewhere between these terminals, through the motor, through the switch, and back to this terminal. Okay, so let's get it open, see if we can find that broken wire. Okay, so looking at this, the number of screws here, it would suggest that this cover splits in half. And looking down the spine of it here, there seems to be a join all the way up here, round here, up to here, but there's a join round here, okay, and one here. So it looks like if I undo these screws, this whole section here should lift off. We've also got this knob here which passes through there, so we're going to have to take that off. Okay, that just pulls off and goes in our tray. Right, let me get these screws out. Right, there's a lot of screws. It looks like now that should be all of them. So this should, in theory, lift off, which it does. And I can already see what the problem is. Okay, let me show you. Okay, so here's a closer look. This is obviously the connection where the battery goes. These two wires come along here, go through the switch, along here, and up to the motor. Okay, so that was the simple circuit diagram that we drew over here. Okay, that's basically what you've got here. Okay, there's some additional circuitry here for some little lights, okay, and a test button, but we're not interested in those at the moment. We're just interested in this bit, and I can see the problem, and the problem is here. Look. Okay, that's come off of there. So that means when I was moving it about and it was starting and stopping, this was obviously, that wire was touching and breaking, making a breaking on this terminal here. Okay, so what I'm going to do is quickly solder this back together and then do our continuity check again using our meter through the whole thing, and we'll see if that's fixed it electrically. Okay, spark up the soldering iron. Alright, let's wait for that to heat up. Okay, so now I've re-soldered that very quickly, very badly, but it will do for now. Okay, got our test set up again here. We're on resistance. We're looking at that. We're connected to these two terminals. If I pull the trigger, this should then go down to a very, very low reading. Okay, 3, 2, 1, push. There you go. Right, so what does that tell me? That tells me that there's continuity between this pin all the way through the switch, through the motor, back through to this pin, to the meter. Okay, so I'm confident now that I can put the cover back on, plug the battery in and give it a try. Right, it's all back together now. Remember, when you're putting it back together, make sure all of the bits of bodywork all go back together nicely, so there's no gaps anywhere. There's nothing worse than seeing a power tool that's been played with and there's bits of it hanging out everywhere. Also, if you trap a wire, obviously you can end up with different problems. Make sure things like the switch is seated properly, and obviously things like this bit here, make sure it's correctly fitted. Okay, so that's all back together. Let's plug in the battery. I still haven't put the blade on it, just in case. Battery's on. Okay. And also our light indicator here. That is now working. Okay, so I'm quite happy now to put the blade back on this and maybe carry on using it. Okay, so that's about it. We've now fixed our circular saw. I can carry on using it, so it saved me buying a new one, even though we all like buying new tools. So it didn't actually cost anything. All we used was a voltmeter. So if you're interested in anything like this, or you would like to go through how this works, just drop me a comment and I can possibly do a video about using a voltmeter or some basic electrics. Okay, right, don't forget, if you've got newer power tools and they're under warranty and you start playing about with them like this, it's your responsibility. Okay, you will invalidate your warranty and also you could end up running into trouble. Okay, I've only fixed this because I paid for it, it's out of warranty and it only worked for a short period of time. I possibly could have taken it back, but I decided to keep it. So the responsibility is entirely mine. Okay. What you do with your tools is entirely up to you, okay? Even though I'm a qualified electrician, I cannot condone you fixing your own tools. I'm just showing you the basic principles of how it works and how I fixed it. Okay, that's enough of the disclaimers. I hope you learned something so you know what's happening when you do get your tools repaired. Okay, thank you very much for watching and I'll see you in the next video. Bye. Or a jigsaw. I'll try that one again. Because they're all battery powered, the principle is going to be the same for the fault finding. Now when you're putting it back together, make sure you don't trap any wires, make sure the seat is switched properly. So the basic idea was